Good evening. It's me, Iman, from Joshua University of Science and Technology, Department of Mathematics. Today, I am show my presentation on our linear algebra course. The topic is generators. So let's start. Now I share my screen. Welcome to my presentation from group number 4. My topic is generators. I am Iman Baroy. My student ID known is 181516. So let's start. My first topic is generators. What is generators? Generators means to generate some things from another things. So whatever generators in linear algebra means, let's S be a uh, vector set, be a finite subset of a vector space V of F if U another um, linear combination of alpha V1, alpha V2, and the nth number of alpha 1 V1, where all of the U is the U belongs to the V. Uh, and all the scalars numbers alpha 1, alpha 2, and nth number of alpha 1 are belongs to the our vector field F. So S is called the generators of vector field of F, and it is generated by Vf equal to angular vector S, and V of F is called generated or spanned by S. There is another definition. If any vector V belongs to vector field V is said to be generated by a vector v1, v2, and the nth number of vn if V can be expressed as a linear combination of v1, v2, and vn. Whatever I say, it's meaning that in shortly, I said that if U and P is a vector space, then U belongs to V. Then we can write this combination of sentence, and we called it that if we show this vector field as an expression of another another vector field, then uh, another vector field and express a linear combination, then we called this vector is a generators of that vector. It means uh, is spanned by V. Here another topic is spanning sets. What is a spanning sets? Spanning sets mean if every vector in a vector space can be written as a linear combination of vectors in a set, then it is called the spanning. This is called the spanning of vector space. Let's S equal a vector set v1, v2, and the kth number of v. Then the subset of vector space v is the vector space V. The set S is called a spanning set of V. If every vector in V can be written as a linear combination of vectors in S, in that case it says that S spans V. So it means if any vectors S spans VC or V is generated on S, then we call this these vectors spanning sets. How can you take it shortly? I make in one sentence that the definition of generator is called that it any sentence can be expressed as a linear combination, then this set is called to be a generator of vector space. It means the vector space is spanning sets, and the following linear combination sets expressed sets as defined as a generators. So it's maybe more effortable to show an example. Here is the example. Determine the vector S, where is the three components 1, 2, 3. The first component is just 1, 2, 3. The second component is just 0, 1, 2, and the third component is 0, 0, 1. It spans R cube. So there is the solution. The given set of vectors spans R cube. Whatever any arbitrary vector v abc or any unknown scalars xyz belongs to R. The given vectors can be expressed as a linear combination of v. Then we say that the linear combination of v. Then we can write that v equal to ABC equal to x, that's the following vector 1 2 3 and y into 0 1 2 and z 0 0 1. Then we can write v equal to ABC equal to x, this means x 2x plus y and 3x 2y plus z. Equating these components, we can write the following for forming system as a linear equation: x equal to a, 2x plus y equal to b, 3x plus 2y plus z equal to c. Solving, we get x equal to a. Solving this equation, we get this, and thus we can write the following linear combination of sets: a into 1 2 3 plus b minus 2a, whatever we get from the previous line, and 0 1 2 is comes from our vectors field, and 0 0 1 and a minus 2b plus c comes from our z values. Since the vectors can be expressed as a linear combination of v, so the given sets of vectors spans r cube. R cube means there are three components of v: one component, second component, and third component. That means s is called the generator or spans of r cube. My second topic is basis. What is basis? Let's V be a vector space over the field F, and V1, V2, and the nth number of vector field F be a finite set of vectors V. Then the V1, V2, and the nth number of V is called the basis of V, and only if there are the following vector components is linear independent and the vector components spans V. However, the definition of basis comes from that a vector fields a vectors S, its components v1 v2 and the nth number of v, and in a vector space v is called a basis for v if the following conditions are true. Number one, S spans V or S generates V, and number two condition, S is linear independent. There are also show that a standard basis. What is a standard basis? If a vector, two vector space, and then the 1 0 and 0 1. This means one component, second component. And this is the second vector field of F. If this is the nth vector field, then it is 1 0 0 and 0 1 0 0, nth number of 0, and 0 0 0 10 0 is the standard basis of uh, basis. And there show example show that the following sets 0 0 1 0 0 0 1 0 0 0 1 are the basis of R cube. And so solving is the given vectors will form a basis of R cube if it's be a linear independent and the vectors spans R cube. So we first show our first condition. To show the given vectors as linear independent, we must show that the matrix whose rows are given vectors. We write the following vectors in matrix from, and the matrix is now row echelon from which has no zero rows, so that the given vectors are linearly independent. So the our first condition is satisfied, and the second condition is the vectors spans of R cube. So the previous slide I show that how can we spans R cube. This way we spans a vectors R cube. So that the given vectors R cube, we must show that x y z belongs to R, where the arbitrary vectors v equal to abc can be expressed as a linear combination of the given vectors v equal abc equal x into 1 0 0, y into 0 1 0, and z into 0 0 1. We get this x from the belongs to our R vector, and the component 0 0 1 0 0 we get from our following vectors field. So we can write this our vector abc equal to xyz, and equating the corresponding sides we get x equal to a, y equal to b, and z equal to c. Thus v equal to abc equal to a into 1 0 0 plus b into 0, 1, 0 and C 0, 0, 1. We write our following vectors as a linear combination. That's why we call this the vectors are linearly independent and can be expressed as a linear combination of an arbitrary vectors. That is vectors spans R cube. That how there are first component, second component, and third component. This means the vectors fields are spans R cube. So therefore, the given vectors from and the given vectors are the basis of our basis and it's of R cube. So thank you everyone. I think it's go it's understood everyone. Thank you for everyone to